Hello, this video is going to talk about dividing polynomials. We're going to start out with a very simple example where we're dividing two constants. This is just meant as a quick review of how long division works. So if we're dividing 782 divided by 3, we set up long division like this using this kind of division symbol. We then look at how many times does the number 3 go into the number 7. So 3 times 2 will be 6, which is just a little bit less than 7. So 3 goes into 7 2 times. 2 times 3 is 6. I'm going to write the 6 below the 7, and we're going to subtract. 7 minus 6 gives us 1. We now carry down the 8, and we ask ourselves, how many times does 3 go into 18? Well, 3 goes into 18 6 times. We multiply 6 times 3 to get 18 and subtract again. 18 subtract 18 is 0. We carry down the 2. So now how many times does 3 go into 2? Well, it doesn't. So 0 times. 0 times 3 is 0. We subtract again, and we have 2 left over as a remainder. So we say that 782 divided by 3 is equal to 260 remainder 2 is what was left over. Another way of writing this is 782 divided by 3 is equal to 260 plus 2 thirds, or in other words, the remainder of 2 has yet to be divided by 3. So if we were to continue this by adding a decimal place with some zeros after 782, then we would get 260.666666, or about 2/3. So this is another way that we can write that conclusion at the end. 782 divided by 3 equals 260 plus 2/3. So now we're going to use the same kind of strategy to divide polynomials. So here we want to divide the polynomial x to the 4 minus 3x squared plus 5x minus 6 by the polynomial x plus 2. We're going to set it up in about the same way. So x to the 4, I'm going to write out the rest of the polynomial. If you happen to be missing any terms along the way, so here we see we're missing the x cubed term, we're going to write out a plus 0x cubed, and that goes for any of the other terms as well. So if we were missing an x term, we would write a plus 0x. And we also want to make sure that these terms are in decreasing order of the exponent of x as we write it out. So the order of those terms matters, and make sure that you fill in any missing terms with a 0. Okay, and we're going to divide all that by x plus 2. Okay, so to divide polynomials, we're going to start by looking at the first term of, this is called the divisor, and the first term of this is called the dividend. Okay. The answer to a division statement, of course, is called a quotient. So we're going to start with the first term of each, and we're going to say, how many times does x divide into x to the 4? Well, x times x cubed will give us x to the 4. And I'm going to write that x cubed above the x cubed term in the dividend. Okay, now we multiply, just like in long division. X cubed times x gives us x to the 4. And I'm also going to multiply the x cubed by 2. That gives us positive 2x cubed. And I'm lining up these terms underneath the terms in the dividend that match the variable piece. Okay, the next step in long division, once we did 2 times 3, we wrote the 6 below, we subtracted. So we're going to do the same thing here. So we're going to subtract all of this from what was in the dividend above. X to the 4 minus x to the 4 is 0. So I'm not going to write that here, it's just 0. 0x cubed minus 2x cubed gives me negative 2x cubed. We then bring down the next term. Okay, then we repeat. So now I'm going to look at the first term of the divisor and the first term that's listed here. So x goes into negative 2x cubed how many times? Or another way of looking at that is x times what will give us negative 2x cubed? Well, x times negative 2x squared. And again, we make sure we line up this x squared term above the x squared term that's in the dividend. Now we multiply negative 2x squared times x plus 2 gives us negative 2x cubed minus 4x squared. And we subtract. Negative 2x cubed subtract negative 2x cubed is 0. Negative 3x squared subtract negative 4x squared is 1x squared. And we bring down the next term, the 5x. Okay, now we're going to look at the first term in the divisor and the first term that's here. So x times what is x squared? Well, x times x is x squared. So now we multiply. X times x plus 2 is x squared plus 2x. And we subtract again. X squared minus x squared is 0. 5x minus 2x is 3x. And then we bring down the next term of negative 6. And finally, we look at the first term in the divisor and the first term here. X times what is 3x? That's positive 3. And then we multiply. 3 times x plus 2 is 3x plus 6. And we subtract. 3x minus 3x is 0. Negative 6 minus 6 is negative 12. Okay. And now what we're left with here has a lower degree than our divisor. So our divisor is linear or has degree 1, and our remainder that's left here is now less than degree 1 polynomial. This is degree 0 polynomial or a constant value. So this is our remainder. Okay. Similar to the question on the previous page where we were just doing straight up long division, we can write this division in this form. So we have x to the 4 minus 3x squared plus 5x minus 6 when it's divided by x plus 2 gives a quotient of x cubed minus 2x squared plus x plus 3, and the remainder is negative 12. And that remainder has yet to be divided by the divisor. So we write that remainder over the divisor. So this is what's called a division statement. Another way of writing this is by using a multiplication statement. So we know that 782 divided by 3 is 260 plus a remainder of 2 that still has to be divided by the 3. If I multiply every term here by 3, I get 782 is equal to 260 times 3 plus 2. So the first one is known as a division statement. The second is known as a multiplication statement. So it says the same information, it's just written in a different way. I could write a multiplication statement for this. So if I multiply every term here by x plus 2, I get x to the 4 minus 3x squared plus 5x minus 6 is equal to x plus 2 times the quotient, so all of this, minus 12. Because when this term is multiplied by x plus 2, the x plus 2 part will cancel out. So I've got negative 12 left here. So again, the first part is a division statement, and the second part is a multiplication statement.